Okay, dear students, we are in 6.2 exercise application of derivatives. Already started in the last class. We have finished 6 questions. Okay, let us try to solve 6 more questions in this class, 7 to 12. Okay, see what they have given in 7th question. Question number 7. Show that y is equal to log of 1 plus x minus 2x by 2 plus x. This is a function y. We can take it as f of x also, where x is greater than minus 1. You see, domain is already mentioned. X is greater than minus 1 means minus 1 to infinity, but equal to symbol is not there. That is why you have to take open intervals. Okay, is an increasing function of x. Increasing function, like we have to show. Why? Because show that means prove. We have to prove throughout its domain. Its domain is what? Minus 1 to infinity. Entire minus 1 to infinity, this function is increasing, like we have to show. Let us see. We know very well how to do and all. Let us take this as f of x and do derivation f dash x. Okay, see how I am doing. Let f of x is equal to log 1 plus x minus 2x by 2 plus x. Okay, f dash x. F dash x is equal to, you see, d by dx of log. This you can do directly. 1 by 1 plus x. Okay, into d by dx of 1 plus x. 0 plus 1 into 1 means the same. That is why I am not writing again. Okay, minus. Here you carefully you do. Why? Because here derivation denominator has come. U divided by v, like 2 plus x. D by dx 2x is what? 2. Is it okay? D by dx 2x 2 minus. Why? Because division is there. Minus you have to write 2x into d by dx 2 plus x is 1. That's all. Why? Because d by dx 2 is 0. D by dx x is 1. 0 plus 1 into 1. That is why into 1 divided by 2 plus x whole square. X plus 2 whole square or 2 plus x whole square. Both are same. Okay. Okay. Come again here. 1 by 1 plus x. Okay. You see here 4 plus 2x. Why? Because 2x you send. Why? Because 2x are going to get cancelled, like minus 4 plus 2x minus 2x by 2 plus x whole square. Okay. You see 2x are going to get cancelled. 4 by 2x square. 2 plus x whole square. 2 plus x whole square. Cross multiplication I am doing. 2 plus x whole square minus 4 into 1 plus x. 4 minus 4x. Is it okay? First you see. Minus 4 minus 4x divided by. Okay, this you keep it like this only. 1 plus x into 2 plus x whole square. Okay. Okay. Denominator keep like this only. 1 plus x, 2 plus x whole square. But a plus b whole square, a square plus 2ab plus b square minus 4 minus 4x. You see, plus 4 minus 4 plus 4x minus 4x got cancelled. Now you see what will happen. X square by, this will be final. You can keep f dash x is equal to, write down. F dash x is equal to x square by, okay, 1 plus x into 2 plus x whole square. This you box it. Why? Because afterwards we have to utilize this. Okay. See, this is f dash x. Normally what we know, to find interval, this f dash x should be made equal to 0, then one interval will come. Okay. We'll make it 0. Let us see whether this is the same interval or not. If not, then you have to check again. Even though you have to check only, but let us proceed further. For finding interval f dash x is equal to 0, you have to make. Write down. Comma, f dash x is equal to 0 implies. Okay, you see, x square by 1 plus x into 2 plus x whole square is equal to 0. Then x square is equal to 0, x is equal to 0. Is it okay? First you see, x square is equal to 0. When x square is equal to 0, normally x is equal to 0. Unless x is 0, x square cannot be 0. Okay, even minus also is going to become plus x square. Okay. Now, see, minus 1 has not come. That you have to understand carefully. Some peculiar cases will come. Okay. This is a peculiar case like you think. And what I am doing, you see, like this I am writing. You observe carefully. Minus infinity, okay. Plus infinity, okay. 0, it has come. But minus 1 they have given. That also you have to take. You understand carefully. 0 we have got. But minus 1 they have given. Domain. But as per question, domain is minus 1 to infinity. Minus 1 to infinity. Not 0 to infinity or minus to infinity to 0. Minus 1 to infinity is 0. They are applying x is greater than minus 1 means greater than minus 1 up to infinity. But entire this thing, see, it may come 0 to infinity positive. Why? Because increasing like they have told means this normally it will come increasing. But you see, even between minus 1 to 0 also it should come increasing. This is a peculiar case. This side, both side, after making f dash x 0, both side increasing is coming means this is a peculiar case like we can think. Okay. Let us do. See, first what we do, 0 to infinity. What you can take? You can take 1. Here 1. Okay. Write down f dash 1. F dash 1 is equal to 1 square by 1 plus 1 into 2 plus 1 whole square. Okay, 1 by 2 into 9. Okay, that is equal to 1 by 18 is greater than 0. Is it okay? Definitely okay. That means what you are going to write, f dash 1 means greater than 0, increasing. Write down here increasing. This is increasing. Okay, INC. 0 to infinity increasing. Why? Because we have seen now. Now pay a special case. Why? Because already they have asked increasing function, but 0 to infinity is increasing. But what about minus 1 to 0? They are telling that entire domain you have to show. If you are able to show it is increasing in minus 1 to 0 also, then we can write entire domain is increasing. Okay, write down. Okay, take minus 1 to 0. What number you are going to take? You see, minus 1 to 0 means minus 1 you should not take. Okay, minus 1 you should not take. Okay, you take minus 0.5. Well, because you see here 0.5, 1, 2, 3, 4. 0, 0.5, 0.5, 1, 1, 1.5, 1.5, 2. Like that will come. Minus 0.5. You write down minus 0.5. F dash minus 1 by 2. Is it okay? Minus 0.5. Okay, write down. Okay, write down minus 1 by 2 whole square by, you see, 1 minus 1 by 2 plus 1 by 2. 2 minus 1 by 2. Why minus? By because 2 plus x minus 2 minus 1 by 2. Okay, write down 2 minus 1 by 2 square. That is equal to. You see, 1 by 4 will come here. Why? Because even though minus plus will come 1 by 4. Okay. This is also 1 by 2 into. You see, 2 minus 1 by 2, what will come? 3 by 2. 4 minus 1, 3 by 2. 3 by 2 square, 9 by 4. Okay. Okay, write down 9 by 1 by 4 into 9 by 8, 8 by 9. 9 by 8, 8 by 9. 2 by 9 is greater than 0. That means here also increasing. Okay. Now what you are able to understand? See, here you may ask, sir, at 0, how can you say that this is increasing like? You see, 0 you are not taking, but you can take -1 to 0 and 0 to infinity. Both are increasing. Then we can say entire domain is increasing. That's all. Okay, like that also you can say. See what I am writing. Function is increasing on -1 to 0. You see, open intervals, and 0 to plus infinity. Function is increasing. Okay. Therefore we confirm that function is increasing entire domain -1 to infinity. Okay. It may be not applicable at 0, but before 0, after 0, all are increasing only, continuously increasing. That is why we can confirm that this is an increasing function line. Okay, like this you write and close this question. Let us go for 8th question. Okay. See, 8th question. Find the values of x for which y is equal to x into x minus 2 whole square. That means here x is also square, x minus 2 is also square. E is an increasing function. Okay. See, this is an increasing function. They are not asking us to prove. We have to find the intervals. That's all. Okay. Increasing function, where it is increasing, those intervals you have to find. This you have to understand. Okay. Let us proceed. We know very well. Take this as f of x and find f dash x. Okay. Write down. F of x is equal to x into x minus 2 whole square. Okay. What we do? Shall we? Okay. Write down. See, x square minus 2x whole square. Is it okay? X square minus 2x whole square. Then, yeah, you make it x to the power of 4, a square minus 2ab minus 2 into a into b plus b square, 4x square. Is it okay? F of x is equal to x to the power of 4 minus 4x cube plus 4x square. 4x cube minus plus 4x square. Okay. You see, this is f dash x only still. F of x only. F dash x we have to find. F dash x is equal to, okay, 4x cube minus 12x square. 4x cube minus 12x square plus 8x. Is it okay? Okay. See, this is f dash x. This you have to make equal to 0. Then you can find the values. But before that, what we do? We will what we can say, take common and see factors and all we have to make. Let us do it. F dash x is equal to, you see, 4 4 4 common. 4 I am taking, x common. X I am taking common. Okay. If I take such that 4 is already gone, x square will come, minus 4 is already gone, 3x will come, plus 4 already gone, 2 will come. Is it okay? First you see, 4x cube, 12x square, 8x. Okay? Okay. See, here also you can take factors. You see, 1 into 2, 2. 2 into 1, minus 2, minus 1. Minus 3, minus 2 into minus 1, plus 2. Okay? That means minus 2x minus x plus, we can write. You see how I am writing? X square minus 2x minus x plus 2. Is it okay? Minus 3x. Why I can take common like this, you see. 4x into x into x minus 2, x minus 2, minus 1. You see, x square minus 2x minus x plus 2. Okay. What is the advantage? You can write like this. You see, 4x into x minus 1, x minus 2. Is it okay? X minus 1, x minus 2. Okay. Now you see, for finding the values, you have to make this as 0. Okay, write down. Comma, f dash x is equal to 0, you have to make, implies 4x is equal to 0, x is equal to 0, x is equal to 1, x is equal to 2. You see, x is equal to 0, 1, 2. 3 intervals have come. Total 4 intervals are going to happen. Okay, let us write. Let us write these intervals. Minus infinity, plus infinity. You see, first 0 will come, next 1 will come, next 2 will come. Okay, you see here, minus infinity to 0 is one interval, 0 to 1 is one interval, 1 to 2 is one interval, 2 to positive infinity is one interval. You see here, what they are asking, values for increasing function they are asking. See, if at all decreasing are there, then you did not write, you check, but where increasing are coming, those only you have to write, like. Okay, let us proceed. See, minus infinity to 0 means, shall I take minus 1? Okay, where you are taking this. F dash x is this one. Okay, f dash x is this one. You apply 0. F dash x is equal to 0. You have applied. Okay, applied, find. Now you apply these values. Minus 1. F dash minus 1 is equal to 4 into minus 1, minus 1, minus 1, minus 1, minus 2. Okay, that is equal to, you see, minus 4 into minus 2 into minus 3. 8, 24, minus 24. Why? Because see, minus minus plus, again minus is there. Minus 24 is less than 0. That means here, what we can say? Less than 0, here minus 1, this is decreasing. But we want increasing. That is why this we should not take. I think this may come. 0.5, 1 by 2. Okay? Between 0 and 1, 1 by 2. Write down. F dash 1 by 2. 4 into 1 by 2. 1 by 2 minus 1. 1 by 2 minus 2. See, 2 into 1 by 2 minus 1 is minus 1 by 2 into 1 by 2 minus 2 is minus 3 by 2. But minus minus are going to get cancelled, plus is there. Total plus will come. 2 get cancelled. That means, see, 3 by 2 plus 3 by 2. Plus 3 by 2 is greater than 0. That means here increasing. 0 to 1 is increasing. Okay. But even then you have to check 1 by 1 between 1 and 2 and 2 to infinity also. Let us check. Between 1 and 2, 1.5. That means 3 by 2. Write down 3 by 2. F dash 3 by 2. See, 4 into 3 by 2 into 3 by 2 minus 1. 3 by 2 minus 1 dash, shall I write directly 1 by 2? 3 by 2 minus 2 minus 1 by 2. Why? Because 3 by 2 is half less than 2. Okay. 4, 6. 6 into minus 1 by 4. See, 3 2 minus 3 by 2 less than 0. This is decreasing again. Okay, normally like that only will come. Now we take 3. Okay, we take 3. Then this will come increasing. F dash 3 is equal to, why? Because greater than 2 we have to take 3. 4 into 3 into 3 minus 1 is 2 into 3 minus 2 is 1. 12 into 2, 24 is greater than 0. That means here what will come? Increasing. Okay, now go back and see the question. Find the values of x for which this function is increasing. Increasing means 0 to 1, 2 to infinity. Same you have to write, right down. The function is increasing on the function is increasing on 0 to 1 and 2 to infinity. That's all. 0 to 1 and 2 to infinity. Take this, we will go for 9th question. Okay. See the 9th question. Observe carefully here, closed intervals they have written. Not open interval. Prove that y is equal to 4 sin theta by 2 plus cos theta minus theta. This is function. This we can take as f of x. Is an increasing function of theta in 0 to pi by 2. That means in 0 to pi by 2 this should be increasing. Okay. But at 0 also, at pi by 2 also increasing, like we have to show. Like that they are giving. Okay, let us see. We will see how it comes and all. Okay. See, why we can take this as f of x. So directly shall we do f dash x? Write down f dash x. Why? Because f dash x if you do, then you can find what we can say. Not interval. Interval also we can find, but that is not the case. But we can substitute the value. Okay, f dash x only you have to find. In f dash x, these values you have to substitute. Write on f dash x. F dash x is equal to, you see u by v form. V d by dx 4 sin theta, 4 cos theta minus u 4 sin theta d by dx 2 plus cos theta. See, d by dx 2 is d by d theta. D by d theta 2 is 0. But d by d theta cos theta minus sin theta. Minus sin theta means shall I write plus sin theta? Minus of minus. Okay. So we have multiplied. We are jumping one step. Divided by v square. 2 plus cos theta whole square. D by d theta, theta 1. Okay. Okay. Now to what we can say. Calculate 8 cos theta. Okay. Plus 4 cos square theta plus 4 sin square theta divided by 2 plus cos theta whole square minus 1. Okay. Now you tell me 4 cos square theta, 4 sin square theta. 4 if you take common, sin square theta plus cos square theta is 1. That means this value is 4. Okay. Write down. 8 cos theta plus 4 by 2 plus cos theta whole square minus 1. Okay. See what you have to do. You have to cross multiply it. 8 cos theta plus 4 minus. Okay. See, you are okay. You can make one more step. No problem. 2 plus cos theta whole square divided by 2 plus cos theta minus divided by 2 plus cos theta whole square. Now you expand it. 8 cos theta plus 4. Sorry, minus. See, all minus will come. Outside minus is there. A square 4 plus 2ab, that means minus 2ab. Minus 2ab 4 cos theta plus b square, that means minus b square, minus cos theta, minus cos square theta. Is it okay? Okay. Okay. 2 plus cos theta whole square. Okay. Now you see plus 4 minus 4 got cancelled. 8 minus 4 cos theta, 4 cos theta. Is it okay? Minus cos square theta. 2 plus cos theta whole square. Why? Because 8 minus 4, 4. Minus 4 plus 4 cancelled. 4 cos theta minus 4 cos square theta. You see, now you take cos theta as common. 4 minus cos theta, 2 plus cos theta whole square. Is it okay? First you see. Four cos theta minus cos square theta divided by 2 plus cos square theta. Okay. Now, what is our next step normally? This is f dash x. You box it. F dash x should be made equal to 0. That's all. Let us make it 0. Let us make it 0. If you make it 0, what will come? Cos theta into 4 minus cos theta is equal to 0. Okay, this is going to become multiplication 0. Okay, if that is such case, here only we will write. No, here we will write. Cos theta is equal to 0, theta is equal to pi by 2. See, why I have written pi by 2, not 3 pi by 2? Why? Because you are given, here interval I am given pi by 2 only. Why? See, cos theta circle diagram, if you see here, here is 1, here is minus 1, but here also 0, here also 0. 0, pi by 2, pi, 3 pi by 2. Pi by 2, 3 pi by 2. In both area, cos will be 0. But why you are taking only pi by 2? Because they have given interval 0 to pi by 2 only how to take. First quadrant only how to take. Here only. These remaining 3 quadrants you need not take. Okay. If you consider this interval, then theta value will be pi by 2. Okay. That is one thing. Again go for 4 minus cos theta also. Why? Because that also you have to see. Let us see this also. 4 minus cos theta is equal to 0 implies cos theta is equal to 4, which is not possible. Why? Because cos theta value is between minus 1 and plus 1. That's all. Minus 1 and plus 1 only. It is not greater than minus 1, not less than minus 1. Sorry, not less than minus 1 and not greater than plus 1. That is why this value is not valid. You can take see, cos theta value is not valid, that is why theta you need not take. But here cos theta 0 value valid, you can take theta pi by 2. Now we confirm that pi theta is pi by 2. Okay. Now you see, you cannot see that pi by 2 in real line, you can keep this side, that side like. No, this is trigonometry. They have given the intervals. In trigonometry, you have to take intervals like this only. Okay? Not a real line like. You understand? This is a little bit tricky. You have to understand it carefully. You see, from 0 to pi by 2. See, this is values, a range. But what about domain? 0, pi by 2, pi, 3 pi by 2. Okay? This is a range. Sorry, domain. This is domain. Plus, plus, minus, minus. Plus, minus, minus. Okay. Now see, this is domain, this is range. Domain, what you have to take? 0 to pi by 2. Okay? 0 to pi by 2, what will be there? Plus, plus will be there for cos theta. Okay? But at 0, 1 is there, but at pi by 2, 0 is there. 0, okay, it is okay. 1 is there, that is why greater than 1 you can write. But what about at pi by 2? 0 is there. Can we take? But here you have given closed interval. Anyway, you have to show. Why? Because prove that like he is telling. Na? Then how to write this? Like this you write. Okay. See, f dash x you have seen. F dash x. Okay. Write down for f dash x. Cos theta is greater than 0 in 0 to pi by 2. You see open interval only I am writing here. 0 to pi by 2 cos theta is greater than 0. Why? Because see positive. Comma 4 minus cos theta is also greater than 0 in 0 pi by 2. 4 minus cos theta. Why? Because see cos theta value is from minus 1 to plus 1 only. 4 minus 1 or 4 minus of minus 1 is always going to give positive value. This is also greater. 2 plus cos theta whole square is always greater than 0. Why? Because see anything is greater than 0. See, when you have declared that this is greater than 0, automatically greater than 0 plus 2. Greater than 2. Greater than 2 square. Greater than 4. Greater than 4 is always greater than 0. Okay, this also you have to understand. Now once again you write f dash x is continuous. Our function is continuous. Therefore, f of x is increasing 0 to pi by 2. You understand now? Like this you write and close. Little bit tricky this question. Why? Because strictly speaking you cannot understand, sir. Here 0 is there, 0 we should not take. We will take only open interval, not closed interval. But they have asked you to show the closed interval. Like this analogy you write and close it. Okay. Let us go for 10th question. Okay. See the 10th question. Prove that the logarithmic function is increasing on 0 to infinity. Okay. That means 0 to infinity means positive. Positive infinity. After 0, positive infinity. Logarithmic function we have to show that this is an increasing function. Increasing function like we have to show. Okay, we can show it. Logarithmic function means shall I take f of x is equal to log x? This is a logarithmic function. Comma f dash x is equal to 1 by x. This is also okay. Okay, now you tell me you are giving not 0 but greater than 0. What will come? Shall I write 0.1? F dash 0.1 is equal to 1 by 1 by 10. That is equal to 10 is greater than 0. Okay. Whatever the number you give. F dash 10, 1 by 10 is greater than 0. Now you tell me whatever may be the number, if greater than 0, if you give x, is it going to come positive or negative? Positive only, all positive. Then f dash x positive means what is the function? Increasing. Write down. F dash x is greater than 0 for all domain 0 to infinity. Therefore, log x is increasing in 0 to infinity. Log x is increasing in 0 to infinity. Okay. Like this you write and close. Okay. Before that, once again I will write that what we can say graph. You see here, this is e power x, this is log x. Okay, both are opposite. E power x, log x, both are continuous functions only. You see, e power x is also continuous function, this is also continuous function, continuously increasing function. If you increase input goes on, output also going to increase. If you increase input, output goes on increasing. That is why whenever it comes logarithmic or e power x, you straight away you write increasing functions like. Okay, those are not decreasing functions. For your understanding sake, once again I have drawn this graph. Let us go for 11th. Okay, see the 11th question what they have given. Prove that the function f of x is equal to x square minus x plus 1. This is the function f of x. Is neither strictly increasing nor decreasing on minus 1 to 1. See, they have given function and they have given domain also. Okay, intervals. But in this interval, the function is neither increasing nor decreasing like you have to show. That means, see, minus 1 to 1 means minus 1 to 0, 0 to 1 will come. Normally, minus 1 to 1 increasing and 0 to 1 decreasing comes, or minus 1 to 0 decreasing and 0 to 1 increasing comes. Both will comes means automatically we will write neither increasing nor decreasing. That's all. Why? Because see, minus 1 to 1 completely, see, interval may be there, minus 1 to 0, again 0 to 1, both are increasing means we can write increasing. Minus 1 to 0 and 0 to 1, both are decreasing means decreasing we can write. But even though open interval 0 is there in between. Okay, we have seen like that. All these questions we have to do, then only we get experience. Okay. If not like that, minus 1 to 0 increasing and 0 to 1 decreasing, or vice versa, changes, then we can write that neither increasing nor decreasing. That is the what we can say theory we understand until now. Let us proceed. Why? Because once again you write f dash x and f of x and f dash x. Write down f of x is equal to x square minus x plus 1. F dash x is equal to 2x minus 1. Is it okay? Definitely okay. Now see, for finding the intervals, why? Because see, they have given interval, but we have to find the original interval. Original interval called, why will making this 0. Write down 0. F dash x is equal to 0 implies 2x is equal to 1. Okay, 2x minus 1 is equal to 0 you are going to make. Then x will be what? X will be, see, f dash x once for all you, what we can say, box it. X is equal to 1 by 2. That means not 0 but 1 by 2 area you have to see here. Okay, write down once again. See what I am writing. Minus infinity plus infinity. You see, as per our strategy, 1 by 2 is midpoint. Okay, 1 by 2 I have written. But as per examiner, minus 1, 1. Minus 1 is this side, 1 is this side. Is it okay? That means, see, 4 intervals are there, but you need not consider minus infinity to minus 1, 1 to this. You have to see only these two. Why? Because you are asked you to check this only. Minus 1 to 1, minus 1 to 1. But minus 1 to 1 not 0, but up to 1 by 2 you have to see. Okay, let us see. See, minus 1 to 1 by 2 we can take 0. And here you see 1 by 2 greater than 1 by 2 and less than 1. 3 by 4, 0.75. This is half. This is 1. In between 0.75. Quarter. Sorry, 3 quarters. 3 by 4. Here 3 by 4 we will check. Here 0 we will check. Okay. Let us check. Why? Because you are having in front of you only f dash 0. F dash 0. 2 into 0 minus 1, that is equal to 0 minus 1 is less than 0. That means here it is decreasing. Here it is decreasing. Okay. Shall I write decreasing DEC? DEC. Okay. Minus 1 to 1 by 2 decreasing has come. Let us see here. 3 by 4 plus 3 by 4. Okay. F dash 3 by 4. Between 1 by 2 and 1. Okay. See, 2 into 3 by 4 minus 1. 3 by 2 minus 1. 1 by 2. Okay. 1 by 2 is greater than 0. That means here what will come? Here increasing will come. Now you tell me, we are in dilemma. Why? Because see, if they ask minus 1 to 1 by 2, we can say decreasing function. If they ask 1 by 2 to 1, we can say increasing function. But they are asking minus 1 to 1. Minus 1 to 1 means if both comes, we can write neither increasing nor decreasing. Okay, right now. But you first write those words. Okay, the function is, write down. The function is decreasing on minus 1 to 1 by 2. Minus 1 to 1 by 2 and increasing on 1 by 2 to 1. Okay, this you write first. Therefore, the function is neither decreasing nor increasing on minus 1 to 1. You understand the analogy? Like this you have to understand. See, what if both are increasing? Even though interval is both are increasing. One example we have seen, both are increasing but interval is there, then we have to write increasing only. Okay, let us go for 12th question. Okay, see 12th question, little bit carefully how to observe here. Why? Because see, cos x is okay, but cos 2x means how we are changing angles, cos 3x how we are changing angles, and little bit carefully you observe, or else you are not going to get the answer. Tan x is easy. These both are easy, A and D. B and C you have to carefully observe. You see what they are writing? Which of the following functions, among 4 functions, which of the functions decreasing in 0 to pi by 2? In 0 to pi by 2, function should be decreased. You see 0 to pi by 2, what they have given? Interval? Open interval. That you keep in your mind. Okay. We have to draw that circle diagrams also, we will draw. See, without drawing circle diagrams also, you can take the values. Values also you can take and do if you don't want to write circle diagram. But even then, circle diagram is easy. It is applicable for all. Okay. Let us proceed. Then let us take first A. F of x is equal to A. F of x is equal to cos x. Okay. Then f dash x will be what? F dash x will be minus sin x. Is it okay? Is it okay or not? Is it okay? But you see, interval they have given. But even then, for finding interval, what you are going to do? F dash x is equal to 0 implies, see, minus of 0 also same. Total 0 means sin x you have to make 0. Sin x is equal to 0. That means x is equal to 0. See, why x is equal to 0 only you have written, not pi? Because interval is at 0 to pi only is there. But okay, you see what I am telling. What are the circle diagrams? Circle diagrams are for sin theta only. Why? Because see, minus sin theta, f dash x has come minus sin theta. First you box it. Observe carefully how I am preparing. Okay. All silver tea cups. All silver sign, all sign tea cups. Okay. See, first we will write domain. Domain is 0 degree, pi by 2 degree, pi degree, 3 pi by 2 degree. Okay. Then we will write range. At sin 0, 0. At sin 91. At sin pi again 0. At sin 3 pi by 2 minus 1. Okay. 2 minus minus 1, 2 plus plus 1. Like that also you can understand. Okay. This is sin theta, sin x. Okay. Now you see, f dash x, if you make 0 also, x has come 0. That is why, okay, limit is okay. That means interval is okay. You can understand. Now, see, 0 is there, interval. Already they are also given 0. But 0 to pi by 2 they have given. Here, f dash x is 0 means whatever they give, that interval in between you have to take. This is not like real number. Okay. These quadrants only you have to take. See, 0 to pi by 2 they are asking us to do. 0 to pi by 2 is valid. Why? Because 0 has come. Okay. 0 to pi by 2, if you see, all are positive values only. Okay, all are positive values only. All are positive means sin x will be positive. But what about outside symbol? Negative is there. Then finally what will come in 0 to pi by 2? Negative will come, decreasing. Okay. Okay, you write down like this. On 0 to pi by 2, okay, sin x is positive, but f dash x is minus sin x. Therefore, f dash x is negative or less than 0. Okay, less than 0. Actually, sin x is positive, but negative is their symbol. Therefore, f of x is decreasing on 0 to pi by 2. 0 to pi by 2, 0 to pi by 2, decreasing. Why? Because increasing, but minus is going to make it is decreasing. Okay. This is for cos x. You note down, I am rubbing it. Again, we will go back for cos 2x. Okay. See, for cos 2x also same will come. Why? Because again sin 2x, for this also same will come. These diagrams we will keep like this only. Okay. Let us proceed. B cos 2x. B I am writing like this, you see. B f of x is equal to cos 2x. F dash x is equal to, see, d by dx cos 2x is minus sin 2x. Minus sin 2x. Again d by dx 2x is 2. That means minus 2 sin 2x. See, here 2 is there or not also for our calculation that doesn't bother. Why? Because see, minus is important. Sin 2x you have to make positive or negative. See, for decreasing you have to prove. Decreasing function you require. If sin 2x is increasing, automatically this minus is going to make it as decreasing. Okay. But careful observe here. Here this is not x, this is 2x. Then how to write? See, like this you have to write. X is from 0 to pi by 2. Okay. But I will multiply 2x. See how I am writing. If you multiply 2x, so 2 into 0 is 0 only, but here 2 into pi by 2, pi will come. Now see, your domain has been changed. 0 to pi. 0 to pi you have to take. 0 to pi. But fortunately, both are positive only. 0 to pi. Okay? But positive, here, sin 2x is positive, but negative symbol is going to make it negative. Then again decreasing only. Okay? Write down. Sin 2x is positive on 0 to pi. Okay, sin 2x is positive on 0 to pi. But f dash x is negative. Why? Because negative symbol is there on 0 to pi. Therefore, f of x is decreasing on 0 to pi by 2. See, here you are writing f of x 0 to pi by 2 only. But because 0 to pi by 2, f of x only you have to write. But while going f dash x, you have to write 0 to pi. Why? Because see, f dash x is becoming 0 to pi. You understand now? 0 to pi. Decreasing. Decreasing. See, they are asking decreasing. That means 2 decreasing you have got until now. Let us go for third one. Cos is there. This sin x is required. I am not removing this, but I am removing this, and we go for cos 3x also. Okay. Let us go. Cos 3x, comma. F dash x is equal to how much it will come? See, minus sin 3x into 3. Is it okay? d by dx cos 3x minus sin 3x. d by dx 3x 3 minus sin 3x. Okay. Now again you have to make this logic. See, x is 0 to pi. X is 0 to pi by 2. Okay, whatever they give, these values are for x only, not for 3x. That keep in our mind. Then you multiply with 3. This is 0, okay, but this is 3 pi by 2. This is very important. That is why I asked you to observe these two. Cos x tan x easily you can understand, but these two that much easily you cannot understand. Multiplication of angles are there, multiple angles. 3x means 0 to 3 pi by 2. 3 if you multiply. 0 to 3 pi by 2 means you come here. 0 to pi by 2, pi 3 pi by 2. That means up to here it should come. But when you see positive and negative both are coming. Neither increasing nor decreasing. Okay, see, don't bother this minus symbol. When this comes positive and negative both, then neither increasing nor decreasing. See, if it is increasing also, it is going to make decreasing. If it is decreasing also, it is going to make increasing. But what about increasing and decreasing? It is not going to make anything. That is why neither increasing nor decreasing. That means they are asking decreasing function, but cos 3x is not decreasing function. Neither increasing nor decreasing function. Write down first. Analogy. Write down this analogy. What? Because see, sin 3x is neither increasing nor decreasing on 0 to 3 pi by 2. Okay? 0 to 3 pi by 2, neither increasing nor decreasing. Therefore, f of x is neither increasing nor decreasing on 0 to pi by 2. What is f of x? F of x is this one and this. These are not going to change always. F of x is cos 3x and intervals are 0 to pi by 2 while writing final. Okay? Take this, we will go for tan x also. Okay, tan x we have to change this. Okay, let us go. Okay. Now, let us see this tan x. Fourth one. D f of x is equal to tan x. F dash x is equal to secant square x. See, we have to draw secant square x circle diagram. Secant square x circle diagram means what? Secant x and square. That means all negative also going to become positive. Why? Because when secant x is negative also, square if you make automatically positive, it is going to become. Let us do it. Okay. Okay. You see here, this is x only. You did not make that calculation again. X means x, that's all. But you have to write this circle diagrams of secant x. How can you write circle diagram of secant x? By cos x only. 1 divided by cos is going to become secant x. Write down. You see, cos x again I am writing here. See how I am writing. Cos all positive, sorry, all cos, all silver tea cups, all cups. Okay, minus minus. This is cos. Okay, but what about values? Here is 1, here is minus 1, plus 1, plus 1, minus 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 1. 0, 0. Cos x. This is cos x. Now go for secant x. First you go for secant x, then you draw secant square. Okay. This is secant x. Write down secant x. Okay, see, even though positive 1 divided by positive is positive only, 1 divided by negative, negative, 1 divided by negative, negative, positive, positive. These symbols are not going to change. But the values may change. You see, 1 divided by 1 is 1. 1 divided by minus 1 is minus 1. Secant x is 1 by cos x. 1 divided by 0, infinity. 1 divided by 0, infinity. Is it okay? In secant x, infinity will come. Okay. Now go for secant square x. This is square. Now carefully observe what I am doing. These two are plus, okay. But minus, if you make square, what about minus? Minus also going to become square, plus. All are going to become plus in square. Square means all plus, that's all. No minus will be there in square. Okay, 1 square, 1. Minus 1 square, plus 1. Infinity square, infinity only. That you cannot make it, what we can say, infinity square like infinity only. Okay. Now see, this is circle diagram for secant square x. Now you go back. See, x only you are going to give 0 to pi by 2. 0 to pi by 2 you are going to give. But what about this function? Is it increasing or decreasing? Definitely increasing. Positive is there. Okay. See, here you need not get any confusion. Why? Because open intervals is there for this problem's sake. For this question's sake, open interval means 0 you should not take and pi by 2 you should not take. Greater than 0, less than pi by 2, if you take automatically all and values will be positive. That's all. See, even if you don't make a square also positive only. Okay, for secant. But even though you have to make a square, why? Because your answer requires a square. Okay, function. This you have to make. Okay, write down. On 0 to pi by 2, comma, f dash x, that is secant square x is positive, that is greater than 0. Therefore, f of x is increasing on 0 to pi by 2. Okay, like this you have to write and close this question. Okay, see, we have finished 12 questions. We will stop this class here. We will meet in the next class. We will try to solve remaining questions in the next class. Okay, thank you very much.